Ready for our deep dive today? It's a big one.
Yeah, definitely.
LLMs and code security.
Lots to unpack there.
We've got a whole stack of research, and
It's pretty wild, actually.
developers are really embracing these LLMs like
ChatGPT.
ChatGPT, yeah, GitHub Copilot.
Trying to write code faster.
But is it secure?
Yeah, that's the big question, isn't it? There's this one study, over 1.5 million lines of code generated by Copilot.
Wow.
Almost 40% had vulnerabilities.
Seriously.
Yeah, and the biggest issue, not complex errors,
Hmm.
it's how they handle sensitive data,
Oh, that's bad.
especially in web applications.
Like leaking social security numbers.
Exactly. That's the kind of real-world consequence we're talking about.
So it's not just one type of vulnerability.
No, it's a whole range.
Like what else?
Injection vulnerabilities,
Ah.
attackers can insert malicious code.
Like leaving a back door open?
Exactly, and memory management issues.
And even
Cryptographic errors.
which can expose.
Sensitive data.
So LLMs are creating real vulnerabilities.
Definitely, it's a wake-up call for developers.
They can't just blindly trust these tools.
They need to understand the risks.
And one of the biggest risks you said was
Exposing sensitive information like social security numbers or API keys.
right in the code itself.
Yep, falls under CWE 200.
CWE 200.
Common weakness enumeration.
So like a catalog of
Software security weaknesses.
used by.
Developers and security professionals.
Makes sense.
And CWE 200 specifically.
Yeah, what's that one?
It's when sensitive information is exposed more than it needs to be.
Making it vulnerable.
To attackers, you got it.
So LLMs can accidentally make this information too accessible.
That's the problem.
But you were saying that LLMs could also be used
To detect vulnerabilities.
Wait, so they can?
It's like a high-powered magnifying glass for code.
So the same tech that creates security holes can help us find them.
It's kind of ironic, isn't it?
So are they good at it?
Some studies show LLMs are actually better than traditional tools.
Even better than.
Static analysis tools and even other machine learning models.
Wow. Okay, so any examples?
Yeah, there's this study, they used GPT-4 to analyze code from NASA and the DoD.
Department of Defense.
That's the one.
Okay, so what happened?
GPT-4 found and helped fix a ton of vulnerabilities.
Like how much?
90% reduction in vulnerabilities.
No way.
With very little code bloat, too.
That's pretty impressive.
It is, but there are challenges, of course.
Like what?
False positives.
Meaning?
The LLM might flag harmless code as dangerous.
So developers waste time chasing.
Exactly.
So you're saying human oversight is still crucial.
Absolutely can't just rely on the LLM.
Okay, so we've talked about LLMs creating vulnerabilities and detecting them.
Right.
But can they fix them?
That's what everyone wants to know, right?
For sure.
It's still early, but there are some promising results.
Like what have they been able to fix?
Simple things, mostly like memory leaks, buffer overflows.
Right.
For complex vulnerabilities that need deep code understanding.
They're not there yet.
Not quite, but it's a very active area of research.
So we still need humans for the tricky stuff.
For now, yeah. But things are moving fast.
Any promising developments?
Yeah, things like LLM patch,
What's that?
an LLM-based patching system,
And it can fix,
even 0-day vulnerabilities.
which is better than?
Some traditional methods, actually.
So LLMs are becoming more versatile.
Definitely. But you know what's interesting?
What's that?
How we interact with them matters a lot.
How we talk to them.
Exactly. It's all about prompting.
So how we ask is just as important as what we ask.
You got it.
Any special prompting techniques for security?
Yeah, things like chain of thought prompting.
What's that?
You encourage the LLM to reason step by step.
Like a human.
Exactly. It's like giving them a detective's guidebook.
Instead of just saying, find the bad stuff.
Precisely, more context, more guidance equals better results.
This is all fascinating, but I have to ask.
What's that?
Are there any downsides we haven't talked about?
Oh, yeah, definitely. Poison LLMs. What?
Imagine an attacker feeding malicious code into the training data.
So the LLM learns to be bad.
Exactly. It starts suggesting insecure code to developers.
That's terrifying.
It is, and there's evidence it's possible.
Seriously.
One study poisoned less than 3% of the data
And that was enough.
to make the LLM suggest vulnerable code.
Oh,
Yeah.
wow.
And it gets worse.
How?
New attacks are being developed to make it undetectable.
So like what?
Codebreaker, for example.
Codebreaker. What's that do?
It targets how LLMs learn from code.
So it teaches the LLM to...
Recommend specific code patterns.
that look harmless, but...
They have hidden vulnerabilities.
and security tools can't see them?
Nope, making them incredibly dangerous.
This raises a big question for me.
True.
If they can be poisoned to suggest bad code, can they also be manipulated to miss vulnerabilities?
That's a very real concern.
So they could become blind to the very threats they're supposed to find?
It's a chilling thought, but it's something researchers are investigating.
So it's an arms race then? It feels that way, yeah.
Between good and bad uses of LLMs.
And the stakes are high.
The future of code security might depend on it.
Absolutely. It's like we're teaching these LLMs to think like code breakers.
In a good way and a bad way?
Exactly both sides of the coin.
So how do we make sure they use their powers for good?
One way is fine-tuning.
Fine-tuning.
Yeah, like specialized training for security tasks.
So like sending them to security boot camp.
Exactly, make them security experts.
That sounds promising.
It is studies show fine-tuned LLMs can outperform specialized tools.
Even the really good ones.
Yep, in certain situations.
But no tool is perfect.
Right, of course not, and LLMs are no exception.
So human oversight is still key.
Absolutely, developers need to be trained to use these tools effectively.
Understand their limitations.
Critically evaluate the output.
It's like having a smart security consultant.
But you're still the one making the decisions.
Weighing the risks, choosing the best action.
Precisely, and beyond fine-tuning, there's something called vulnerability-constrained decoding.
Vulnerability-constrained decoding. That's a mouthful.
It is, but the idea is pretty simple.
Okay, how about an analogy?
Sure. Imagine building a house.
Okay.
You want it to be structurally sound, right?
Of course.
You wouldn't just let anyone nail boards together randomly.
Definitely not.
You'd have building codes guidelines to ensure it's safe.
So vulnerability-constrained decoding is like building codes for code.
Exactly, you got it.
So it prevents the LLM from making bad decisions.
It sets up guardrails, you could say.
So we reduce vulnerabilities from the start.
Exactly, shifting from reacting to preventing.
That's a big deal.
It is, and it's this kind of thinking that's going to shape the future of LLMs and code security.
We need to be proactive.
Absolutely.
Okay, so we talked about fine-tuning and vulnerability-constrained decoding.
Yes.
But what about prompt engineering?
Ah, yes, that's crucial too.
It's all about how we talk to these LLMs, right?
Exactly, crafting the right instructions, the right questions.
So we get the best responses.
The most accurate and secure responses, you mean?
Right, of course.
Think of it like giving directions.
Vague directions versus a detailed map.
Exactly. One gets you lost, the other gets you where you need to go.
So we need to be specifically deliberate with our instructions.
You got to prompt engineering is a whole field of research.
And what are they finding?
Lots of interesting techniques. One is chained thought parting.
Right, you mentioned that earlier.
You guide the LLM to think like a human expert.
Reasoning through the code step by step.
Like a detective looking for clues.
It makes it so much easier to understand.
And it actually works. Studies show it improves accuracy and depth of analysis.
So it's not just, is this code secure?
It's more like, explain your reasoning, show me your work.
Like a teacher would say.
Exactly. We want to understand how the LLM got to its conclusion.
It's like having a dialogue with the LLM.
A back and forth where we both learn.
We're both refining our understanding
of the code and its vulnerabilities.
This all comes back to context, doesn't it?
Context is everything.
These LLMs need to understand the bigger picture.
It's like a doctor diagnosing a patient.
They need the patient's history, lifestyle, symptoms.
To make an accurate diagnosis, you're right.
So we can't just throw code at an LLM and hope for the best.
Nope. It needs background information.
The code's purpose, its functionality, the potential threats.
All of that feeds into a better security analysis.
So the more context, the better.
Absolutely. More context leads to more effective security.
But how do we actually provide this context?
It's partly about data, but it's also about structure and presentation.
So we need to be curators of information.
Exactly. We select and present the most relevant data.
To help the LLM understand the code in its context.
You got it. It's about turning data into actionable insights.
That's where the real power of LLMs comes in.
Couldn't said it better myself.
Okay, so we've covered fine-tuning prompt engineering context.
We've hit the big ones.
What else is on the horizon? What's the future of LLMs and code security?
One exciting area is using LLMs to generate secure code from scratch.
So not just fixing existing code, but writing secure code from the beginning.
Exactly. Secure by design.
That's a huge step.
It is. Researchers are using things like reinforcement learning to train LLMs to write secure code.
Reinforcement learning like training a dog.
You got to reward good behavior, avoid bad behavior.
So we're shaping the LLM's coding habits.
Exactly. Making security a priority from the start.
That's amazing.
It is. It could revolutionize how we approach security.
Moving from reactive to proactive.
Building security into the foundation of the code.
It's like building a house with strong materials from the start.
Instead of trying to patch up a flimsy structure later.
Makes perfect sense.
And LLMs can help us get there.
This is all very exciting, but are there any downsides? Any risks?
Of course, every powerful technology has a dark side.
Like what?
What if LLMs are used to create malware?
Oh no, that would be bad.
It would, and it's a real possibility as these models get more powerful.
So bad actors could use them for evil.
It's an arms race between good and evil.
And we need to stay ahead of the curve.
Exactly. We need robust security measures to detect and mitigate these threats.
So we need to be vigilant and proactive.
Absolutely. We can't let our guard down.
This brings up another concern.
What's that?
Over-reliance on LLMs.
Ah, yes. Developers might start seeing them as a silver bullet.
and become complacent
Exactly. They might forget that LLMs have limitations.
and make mistakes.
They're tools, not replacements for human
So
expertise.
LLMs are just one piece of the puzzle.
Exactly. We can't abdicate our responsibility for security.
We still need to be in control.
Absolutely. Making the decisions, understanding the risks.
Like any powerful tool.
Like a chainsaw.
Exactly. You wouldn't just blindly trust it
You need to know how to use it safely, effectively.
and be aware of the risks.
Exactly the same goes for LLMs.
They can help us build more secure software
But we need to use them wisely.
with a healthy dose of caution.
Couldn't agree more.
It's clear that LLMs are going to change how we write and secure code, but how will this affect the people involved? What does the future hold for developers and security people in this new world of AI coding?
That's the big question, isn't it? Everyone's worried about AI taking jobs.
Yeah, will LLMs automate developers out of a job?
I don't think so. I think it's more about changing how we work.
So not replacing, but augmenting.
Exactly. Developers will need to specialize more in things like security architecture design.
They'll need to understand these LLMs to guide them to evaluate their output.
And to make strategic decisions about how to use them.
So it's like the difference between a construction worker and an architect.
Oh, I like that analogy.
The architect doesn't lay the bricks, but they understand how the building should be built, the materials, the safety, and stability.
Exactly, and that's what developers will need to do with code and LLMs.
So we need to adapt our skills in education.
Absolutely, we need to be trained the next generation to work alongside these AI tools.
It's not about fearing the machine
It's about embracing the opportunities.
and learning to work together.
Exactly. LLMs can help us be more productive, more creative, and more secure, but we need to use them responsibly.
Before we wrap up, I'm curious, what are you most excited about in terms of future developments? What trends are you watching?
One thing that's really interesting is the focus on explainability.
Explainability.
We don't just want LLMs to give us answers or generate code. We want to understand why those answers are right, how the model got there.
So it's not just about the what, but the why.
Exactly. Especially for security, trust, and transparency are crucial.
It's like having a security consultant who explains their reasoning.
Exactly. You learn more and you can make better decisions in the future.
So explainable LLMs could revolutionize security.
They have that potential for sure.
What else are you keeping an eye on?
The integration of LLMs with other security tools.
So like combining them with static analysis tools, vulnerability databases, threat intelligence platforms,
Exactly. It's like assembling a superhero team of security technologies.
each with its own unique powers.
Working together to create a multi-layered defense against attacks.
Okay, so exciting stuff, but are there any developments that worry you, any red flags?
One concern is the potential for misuse. What if LLMs are used to automate malicious activities?
Like phishing attacks or creating malware?
Exactly. As these models get more powerful, we need to be prepared for that.
It's that double-edged sword again.
Powerful technology can be used for good or bad.
So we need ethical guidelines, responsible use policies.
And we need to be vigilant monitoring for misuse, developing countermeasures.
It's a constant battle to stay ahead of the bad guys.
It is, but we can't give up.
Well, this has been a really insightful look at the intersection of LLMs and code security.
It's a fascinating and complex field.
And it's changing rapidly.
The future of software development and cybersecurity is going to look very different thanks to LLMs.
That's for sure. Well, thank you so much for sharing your expertise with us today. It's been an eye-opening discussion.
It's been my pleasure.
And to our listeners, we hope this deep dive has given you a better understanding of the challenges and opportunities ahead. Stay curious, stay informed, and as always, stay secure.